So tan alpha is this. So that means opposite by adjacent. Opposite is 3, adjacent is 4 by Pythagorean theorem. This is going to be 5. So from that we can figure out sine alpha and cos alpha. So we know sine alpha is going to be opposite by hypotenuse. So this is going to be 120 into 5 by 3 by 5, and this is going to be cos alpha is adjacent by hypotenuse, that is going to be 124 by 5, and we know there is going to be a reaction force to this because of that surface. So this is going to be the reaction force. This is going to be R. So if we, let's simplify this. So this is going to be 72 Newton, 120 into 3 by 5. This is going to be 96 Newton, 120 into 4 by 5. Now we have to break down this component 3 Newton as along the plane and normal to the plane. So let's do that. So this is going to be, this is normal to the plane, and this is going to be along the plane. Since this is alpha, so this is also going to be alpha, and by alternate angle this is also going to be alpha. That means this is going to be 30 cos alpha, and this is going to be 30 sine alpha. Again we can do some basic calculation. Cos alpha means 4 by 5, so this is going to be 30 into 4 by 5, and that turns out to be, and this is going to be 30 into opposite by hypotenuse is 3 by 5, so this is going to be 6 into 4, that is 24 Newton. So that is going to be 6 into 3, 18 Newton. So this after calculation is going to be 24 Newton, and this is going to be 18 Newton. Now let's read on. The coefficient of friction between the plane particle and the plane is half, that is 0.5, mu equals to 0.5. The particle is held at rest in equilibrium by horizontal force of magnitude 30 Newton, which acts in the vertical plane along with the line of greatest slope. Line of greatest slope is basically the inclined plane itself. Through the particle is this. Now we don't know anything about whether is it about to go up or about to go down. So it says the particle is held at rest in equilibrium by a horizontal force of this. So held at rest. So that means basically this friction is not working here because there is no limiting equilibrium. They did not mention anything is about to go up or about to go down. So we can ignore this altogether. Now, so show that the normal reaction is 114. So for the normal reaction, we don't need to worry about the friction at all. So it's normal to the plane. So that means, so taking components normal to the plane, friction doesn't work perpendicular to the surface, so it doesn't matter here. So upward forces are R, and downward forces are this component 30 sine alpha, which is 18 Newton, plus 120 cos alpha, which is 96 Newton. When you add this up, it is going to be 114 Newton. So the horizontal force is removed. So now it's the same plane, everything is same, just horizontal force is removed, and it is changed to a force that is along the plane. So along the plane, up the slope, so it's a force up the slope, line of greatest slope, through the particle as shown here, an object remains in equilibrium. So what we know, just like before, what components will be the same and what component will be different. So the component of weight, so this and this, so this would be the same. So this is going to be 120 sine alpha, and this is going to be 120 cos alpha, and we know the value of tan alpha is the same. So this is going to be 72 Newton, and this is going to be 96 Newton. So these are going to be the same. Now the reaction is not going to be the same because we know that the reaction force changes every time any force is changing. So the reaction force will always change. then friction is going to be the same, because friction is the quality of the surface. So mu is 0.5, value of mu is going to be the same. So since this time it's held like this in this direction, so we can say friction is, so the friction is going to be in the opposite direction. So it will be like this in this direction. So friction is mu, so mu is 0.5 r, and the force is going to be in this direction. Let me redraw this force, since it will have no component. So this is going to be P in this direction. Okay, so what we have to do is we have to find the value of P, the greatest possible value of P. So the greatest possible value of P is basically maximum friction. What happens here? So along the plane, so what happens? Along the plane we have the force P, and we have the other force. One is 72 Newton and the other is 0.5 r. This is along the plane. In order to find P, we need the value of r. So normal to plane. So normal to the plane, we have r equals to 96 Newton. So because this is equals to this 120 cos alpha, and cos alpha is 96 Newton. So plug in the value of here, so we get, therefore P equals to 72 plus 0.5 of 96, which is basically 72 plus 33. Actually, divided by 2, it should be 332. Divided by 2, it should be 4 2s are 8, 48. So if we now add this up, this is going to be 0, so 120 Newton. So in question number C, we have find the magnitude and direction of the frictional force acting on the particle when P equals to 30. So if we change the value of P and think of a different situation, so what is going to happen? Now first of all, when this happens, normal to the plane, the reaction force is not going to change, because the value of P does not affect the component 120 cos alpha. So reaction force is still going to be 96 Newton. Now what's going to happen is the frictional force. Now what's going to happen to the frictional force now? So if we calculate the frictional force, if whether this is going to be in equilibrium or not, we don't know. So find the magnitude and direction of the frictional force acting on the particle when this happens. So let's see what would happen if P equals to 30 and we have downward force. 120 sine alpha is 72. So the total downward force is going to be 30 plus 72, and that is going to be 102 Newton. So that is going to be the total downward force. Now let's check what is friction going to be, maximum friction. So maximum friction is mu r. So mu is half and this is 96. So 96 into half is 48 Newton. So this is maximum friction. So object would move downwards or down the slope. Friction would be up the slope.